Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Editor-in-Chief at Automation World, and the question we'll be answering in this episode is, can humanoid robots be effective in manufacturing? Joining me for this discussion is Karthee Madasamy, the founder and managing partner at MFV Partners, a deep tech VC firm focused on robotics investments. And just so that our listeners know a bit more about Karthee and MFV, they were among the first investors in Agility Robotics, one of the largest makers of humanoid robots. So thanks for joining me today, Karthee.
It is my pleasure, David. Good to join you.
So, to start off with, I've seen in my role, as an editor with Automation World, I've seen autonomous humanoids in various demonstrations, as well as those that, I'd say are a bit suspect in terms of their true autonomy, which I'm sure you've seen too. They appear to be more remotely controlled than really autonomous. So coming from your experience working with an array of robotics companies, what do you see as the true state of the art today for autonomous humanoid robots in terms of their navigation capabilities, their handling capacity, speed and accuracy, the typical robot aspects that, we look at in terms of what they can do?
Yeah, sure thing. It's pretty interesting. For a long time, it was not tickling anybody's whim, and then suddenly now in the last year, everybody is very interested in humanoid robots. So we have seen a lot of people coming up with demos and whatnot. I don't want to, I cannot speak for other robotics companies, what exactly they're doing and how exactly they are showcasing some of these things. But what I can say is what Agility has so far showcased, and you have seen it operate like autonomously for several hours in the conferences and whatnot, right? So Agility has been able to provide these autonomously functioning humanoid robots, both for customers but also for public viewing. I think the capabilities are increasing pretty fast, right? I think even with Agility, we've been watching, what all they can do. They had like a very simple squeezing type of an arm to squeeze the thing to lift stuff up. And now they have, 2 fingers, and then they're showcasing more stuff as well. So I think the capability is increasing day by day. And for a lot of the basic functions where a human form factor is required, I think today, at least for Agility's robots that I can see, can actually be deployed, functional, can be used. There's still more to be done because a humanoid form factor obviously is probably one of the more complex robotic function, because you need to balance as well, and then you need to be able to recover, whereas a wheel-based robot probably doesn't have those type of constraints. So from an engineering perspective, it's probably one of the most complex things, which is probably the reasons why we're not seeing a lot of companies showcasing these things, whereas in every other robotic category, you'll see like 30, 40 companies doing that. I'm sure in the next few years, we're going to see more of that, but I think because of the complexity of the technology or the challenge, I think we're seeing that now starting to slowly happen, but it is a big feat to accomplish. I do think that for a lot of the functions that humans do in factory floors or warehouses and settings like that, it's a lot of repetitive tasks which require a little bit of dexterous manipulation. It needs like a little bit of stacking, destacking, a little bit of aligning things together, a little bit of picking from like ad hoc places and whatnot. Those are places where like humanoids can actually do very well. Go reach below, reach above. Turn around, move around here, and things like that. Smaller spaces and whatnot. So we definitely see that there is enough use cases that we can deploy. And I think as the capabilities increase, I think that it's going to get more and more widely deployed, I think.
And to your point there about what you've were describing that they largely do at this point, and I've seen that the humanoids, demonstrated by picking, placing, and carrying boxes or materials from one place to another, but not really a whole lot more than that. No, like fine motor skills of drilling or welding or anything like that. So is that kind of, would you say, kind of the state of art today is carrying and moving, as basically a transport system is largely where it's at currently, anyways?
I think that it's going to go in steps, right? I think if you think about it, like what humans as we do, right? Like we do a bunch of different things, right? We obviously do this complex picking and placing. We move stuff around. We kind of adjust to wherever the space is, how to pick something up based on the space, based on the object, and all those things. And then we obviously also do dexterous functions as well, like you're talking about a screwdriver and things like that, right? I think we have to, our fundamental thesis was that it's never going to be just one type of a robot, which is going to be this, fits every category type of a thing. You're going to have, even at a steady state, multiple types of robots, right? So, for example, if you're thinking about this dexterous, I need to do this, very fine tuning of the, of screws and things like that. There are different types of robots that can do that, right? And then for moving large, heavy goods and stuff like that, there are different types of robots, right? I think what is the role of a humanoid robot is to kind of connect all these things, because that's what humans are doing at this point. Like there's already automation there. Like goods are coming in, and then there is arms picking and placing. There is vacuum-based stuff. There are precision control robot type of a system which are just placed on a line or something like that. And we just, humans are just connecting all these dots at this point. Right? I think that's the role humanoid is going to play. But I think in terms of, which is why the way we look at it is that, by the time the humanoids are going to just exactly replace humans is not how we think about it. The way we think is that there are going to be different types of robots, and human form factor is going to have an important role in it, which is very complementary to the other types of robots. But I think the next step that's really coming is dexterous manipulation, right? Like, so if you really think about it, right? Even for picking, stacking and things like that, there's going to be need for dexterous manipulation, right? Like, I think that is the next one that's coming. But do you ever going to go all the way to, okay, now I'm going to be doing this, putting a screw together type of a thing, or if there's a case where something needs to be, screwed using a nut and things like that, there might be a different automation system, right? So, but yeah, I think to answer your question, dexterous manipulation is the next one, the big thing that's coming. But I also want to kind of maybe sit back a little bit and say that, okay, it's not going to be exactly like what our humans are going to be, and there's going to be all sorts of different types of robots that's going to be there even in a steady state scenario.
Interesting. So it's not like humanoids are going to be a total replacement for, you're still going to have the robot arms, the AMRs doing their tasks that they're very specific and very proficient at, while humanoids will fill some other roles. Is that a correct assessment?
That's the way I think about it. You're going to you're going to basically try to see, okay, this type of an architecture is best for just moving bits around. Okay, do that architecture. Okay, this type of architecture is very good for just doing pick and placing in a table setting or in a line setting. Okay, and then but you need to connect all these things. You need to do a few things here and there. Like a humanoid could be a good fit, right? So. And I mean, even like humans, that's what we do, right? Like maybe up to 20 kilos, we'll do everything. But if it's about 20 kilos, we are looking for some other tool to basically lift it up and stuff like that, right? So, if you just extend that paradigm to the robotics, it's going to be the same way, right? Like humanoids will do certain things. For certain other automation, we'll have a different form factor.
So what about the technical challenges with deploying humanoid robots in a manufacturing environment? Will they require additional infrastructure or changes in process design, or will they be more like modern AMRs where you can drop them in the environment and they learn the environment? How do you see that, at least currently, for humanoids?
Even AMRs have a little bit of learning. They need to understand the space, where it is, what the contours are, and where they need to drop stuff off and whatnot. There's definitely a little bit of a configuration, and then the warehouse management systems have now, in the last maybe 5-6 years, learned how to basically incorporate that. We have made investments in the AMR space as well. There's still a little bit of a work involved. So there's how do I integrate this thing? How do I change my workflow? I think now we have come to a point where it's reasonably well understood, but even now there are a lot of greenfield customers where there's a learning process. So humanoids have certain advantages. There are certain differences as well. Given that there is similar in navigability and things like that, it's the learning process reasonably similar. But in terms of the workflow, I think it's a slightly different process now. How does a management system or a resource planning system going to use these as a resource for allocating tasks and stuff like that? I think that's going to be a little bit of a learning. I think like one of the things that we are seeing through Agility and Agility's customers is that that's the part where the customers are learning quite fast, and then but there is some learning from their side to figure out how to do it. But in terms of the actual infrastructure itself, obviously you need a charging station, which is similar to for AMRs as well. So you need like a little bit of a charging space to go charge and come back. The human interactions maybe need to be slightly more sophisticated, because the AMRs are just like moving objects, but this one has like hands and stuff like that as well. There may be more complex interactions, and then they're also probably more toe to toe or shoulder to shoulder as well. So how do you interact or how do you work with a human in the loop is maybe a little bit more learning. So that's the way I think about it. But I think the biggest part I see is about the customers figuring out, okay, how they're going to divide their labor, divide their work tasks into what will be the humans doing, what will be one type of robot doing, what will be humanoids doing. That is a process that's where the learning is. And then obviously safety is a big area as well, which is probably similar in the AMR case as well, but I think because of the human form factor, there is this more psychological effect, and also maybe additional dimensions of interaction that need to be addressed, I think.
So it doesn't sound like they're that dramatically different than 6-axis or AMRs implemented. It sounds like a lot of the same requirements to bring them in, nothing dramatically different with humanoids. Is that fair assessment?
Yeah. In fact, with the AMRs, I've seen that, hey, we need epoxy floors. We need to have, you cannot have like a, small stepping thing, whatnot. You cannot deploy an AMR. So there's like a lot more things actually, even for deploying AMRs, had to go through. I think humanoids actually are lesser in that sense. That it doesn't have to be like a smooth floor. It can be a little bit of a gradient is fine, because it knows how to step around it and whatnot. So, and then, depending on how far they are traveling around, we got to see. But a lot of the humanoids probably are in a reasonable cell type of a thing where they are walking around that thing. So the navigation, even though is more complex, but it's also probably a little more constrained as well. So we have not seen that as a huge issue. But obviously, as we deploy more, you're going to learn more as well.
So, what about maintenance? Earlier you were talking about, just the obvious higher levels of complexity with humanoid robots versus, a 6-axis or AMRs or what have you now. So I would think, the maintenance requirements will be several factors higher than that of, the robots we're more familiar with in manufacturing. Can you speak to that a bit? And is that something that the robotics companies themselves will provide, or is that something that manufacturers themselves will need to step up and have robotic experts on hand? How will that be handled, since it is, as you noted, a very complex piece of machinery?
Yeah, it is a complex piece of machinery, and it has definitely more number of components, right? Like a mechanical components, right? I think in terms of all the components together, even AMRs are pretty complex as well. But I think like mechanical components, there's probably more components. There is a transmission, there is a more complex transmission and stuff like that. So this is where the robotics companies make a difference, right? Like you well-engineered robotics companies will do much better than mediocre or average, or just above average type of companies, because how do you handle all these parts, and then if some malfunction happens, how do you quickly replace and stuff like that, right? So a well-engineered company is extremely important, so that you make sure that you have the tolerance levels are pretty good, and then you have a good modular design to quickly replace stuff as well, right? But I think having said all that, there is a way to manage some of those things, right? So the transmission is has issues here, there's balance issues here. Okay, we may not modify, change a leg, or we have to change the arm, or we may have to take this component, do this, replace it type of a thing. Right? So there's a little more complexities, but it can be engineered and it can be modularly designed. And in terms of how exactly it will happen, I think one of the things that Agility has done, and I'm sure others will do the same as well, is that you work with kind of partners, system integration partners, and other partners who could provide a little bit of that type of a first level of support as well. I think expecting the customers to do that maintenance, I think initially that's probably not going to be the expectation, right? I think the expectation is going to be either the robotics company does it, or they're going to work through this network of partners, network of system integrators, network of last mile solutions that would probably take care of it. And I think this is where the ROI could actually either come to a screeching halt if it's not a well-engineered system, because you're probably spending a lot more time on maintenance and replacement and stuff like that.
And we hear that a lot just with basic articulated robots, for the manufacturers needing to either upgrade their own capabilities at maintenance, or they haven't done it. Now they've got the arm that's just sitting there in the corner going unused. So it seemed to me that it would follow that something like a humanoid robot would definitely require integrator or OEM handling. So thanks for clarifying that. What do you see as the first viable applications for humanoids in manufacturing that would generate enough of an ROI to, make them worth the cost? What are these key applications for them?
There's a bunch of tasks right now humans are doing, which are very repetitive, which are in and around constrained stuff, which are a little bit ad hoc, where you cannot purely put an automation system there, right? So that's why humans are still doing it, right? So which could be connecting kind of islands of automation, meaning that good comes in through an AMR, and then you need to put it on another rack or another place and stuff like that. Or a bins come through. Once the packing is done, you got to move it around and then restack it. There's a bunch of these things that humans are doing today, right? I think that's the first level where anything that a human is doing, and then it's probably lots of smaller number of things where you cannot think about putting an automation, or it's going to be expensive to put an automation, or it's not convenient to put an automation. Okay, right now humans are doing, so humanoids can do, right? I think just in that, there is enough use cases and this is even without the dexterous manipulation. This is just moving things around, stacking stuff, putting it in the top of the tray, taking it from the bottom of the shelf and things like that, right? And in terms of the economics, right, I think today, we have invested in a bunch of robotics companies, and we have seen enough robotics companies, right? A robot as a service, we are seeing anywhere in developed market like the US, we're seeing anywhere from 4 or 5K a month to 10K a month type of a range of prices, depending on the dual shift, depending on how complex the capabilities are, and then how the labor availability for that specific job function is, and stuff like that, right? So this is the price point that we're saying, anywhere from 4.5K per month to 10K. Humanoids can comfortably be profitable for everybody, right? Like for the robotics people, and also for the buyers of these robots, the manufacturing companies or the manufacturing line, to make it worthwhile for all parties involved. So in terms of the economics and ROI, I actually think that even today, as long as it's a well-engineered system, you can actually make this worthwhile for everybody involved, right? And I come from a wireless background, cell phone industry, right? Like the phone that we hold in our hands, we're buying it for even the most complex one for $1,000, right? And that has a lot more complexities, a lot more capabilities in it, right? So the robots' prices of costs of building these robots, they're only going to go down, right? There is as soon as the volumes pick up, they're just going to go down, right? Because I don't see a reason why it needs to be that expensive. So they can all easily go down in price, at least an order of magnitude. But right now there's not enough volume, and then the economics make sense even at this current stuff right now. So everybody's learning and things like that. But I think I expect that to go down, and which basically means that the ROI part is not going to be an issue at all. I think the way I think about it is that automation is here, and it's not necessarily just trying to replace humans, it's also just enhance humans in terms of how to increase productivity without putting people into this repetitive task type of stuff. And then the economics make sense even today. I think the question is the more advanced capabilities that you can add, I think the industry will absorb it, right? I think, I remember when I was doing a startup, in the 90s and early 2000s, like manufacturing sector was a hard sector to go sell technology into because, they were not really taking technology in. So you wouldn't really, they're always a later adopter of stuff and whatnot. But I think I would say in the last 4 or 5 years that I go to Modex as well, and ProMat, and when it comes to automation, they're hungry. They're like, we can take automation. We can, and it's not necessarily to just replace humans. It's just like, okay, how do we increase the productivity here and things like that? So, anyway, long story short, like the way I think about it is that even in current prices for very small volumes, the economics will work for both sides, both the buyers of the robots and the sellers of the robots. And it's only going to only get better because the price are going to come down as the volumes go up, and then also as you ride the technology go a little bit more.
So just to clarify, to make sure I understand, so you're seeing that humanoids will likely be roughly in the same cost factor range as the standard robots that are available as a service now. Was that an accurate?
That's what I think, and I think even at those price bands that I talk about, which is where a lot of the robots are right now, I think humanoids probably allowed to fit into those price bands. Obviously, in some cases, they will be able to sell it for higher or lower, whatever it is, right? But they have to. But what I say is, like, in current technology, you can live in that price band and then make it economically viable for all parties involved, the robotics folks and also the buyers, right? And I think it's going to get better and better. You're going to be able to actually reduce the prices, so maybe it's even better for the robotics manufacturers. And then which basically might reflect back as like lower cost of the robot as a service model for the buyers, or maybe even better economics.
Thanks for clarifying that.
Yeah.
And can you share any examples of factories that have integrated humanoids into their operations so far? Or has it just been pilot projects and tests that have been done so far? Because that's what I haven't seen a full end-use case study so far. I've just heard about the pilot projects, but I don't know if you're seeing things, even if the company can't be named, if there's some that are actually using it yet, or is that still just in the testing stage?
There is a bunch of activities happening, and as these are all like, every company holds onto these things when they want to announce it and stuff like that. What I can say is that the interest from manufacturing folks to deploy this is extremely high. I will wait for the companies to actually announce these the actual deployments. Agility has announced the GXO deployment, right? Like the others, I think I will wait for them to announce it. But all I can say is that the interest is pretty high, and there is a bunch of efforts already happening. But I think these type of deployments have as its own time frame as well. It's not just deploying a software to say, okay, all right, I tried this for a couple of months, now I just go live type of a thing, right? So because these all have like the implications, physical implications of a bunch of different things. So we just expect like 2025, you're going to see a lot more announcements of, hey, we deployed for this particular use case type of a thing. You're going to see a lot more of it coming. And then this is always the way it works as well. It starts off slow because there's a bunch of work is happening in the background and whatnot, and then and it's upon the robotics manufacturers to make sure they're delivering a well-engineered product, right? Otherwise, you're going to basically go back and say, it didn't work. And the point that you made is right? Like there is a bunch of robots that are not being used, right? So when I look at an investment for a company, one of the first things that I look at is that how much is it used and how much is it used without babysitting it, right? Like, somebody babysitting all the time, or is it being used, right? So it's also upon the robotics companies to make sure they deliver well-engineered parts. But I think in terms of the interest from the other side to actually go deploy it, it's just very, very high. It's just very high, right? And then, and everybody's going to start slow because they want to always say that, okay, I need to put it on one line, I'm going to put it on one cell, I'm going to put it on a one constrained area first to make sure it works. And then just explode it, right? So I think like it's still a very young product category, right? But I think, we talk me as if AMRs have become like a very well established product category, but it was a product category started only like a few years ago as well, right? So I think like if you just fast forward a couple of years, we're going to be talking more about, okay, this deployment, this many thousands of numbers, hundreds of numbers type of a thing. So, so what I would say is that you're going to see probably a lot more announcement in 2025.
Okay, so you're saying that this isn't really that far off. You're saying in the next couple of 3 years, we're going to be seeing a lot of this. It's not a 5 to 10 year time frame that we're talking about, more in the 2 to 5 year.
Yeah.
Now, for this next question, Karthee, I realize the answer to this is going to depend on the robot provider, but can you speak to the general expected cost and ROI for these humanoids? I know you touched on it a little bit, in terms of its relevance or connection to, the robots as a service, but can you provide is there any further insight into that, or is that kind of the state of where things are now in that range of costs?
So the reason I'm just hesitant to go into these things is that all these costs and prices are going to change based on volume, right? Like if you build just one, it's going to be pretty expensive, right? But if you build even like 100, it's going to be like it's going to go down significantly. And then, like I said, like I come from the cell phone industry where like there's enough prices you can bring it down as well, right? So I wouldn't judge any of these folks' prices or cost based on one part or based on the first few units that they have built, right? Like, and that's true for not just the humanoid robots. That's true for any hardware thing that we look at. We don't look at this like, okay, what is the price or what is the cost for this building that 1 or 10, right? We always look at like hundreds, thousands, 10,000s type of a thing, right? I think even at hundreds or thousands, I think the price point of this 4 to 10K is going to be economically viable for the robotics manufacturers, right? So you can then figure out what kind of cost base that they can bring it down to, and there are folks that are going to buy it as well, instead of doing it as a service, because it just like who takes the financing risk and stuff like that, right? Like financing maintenance risk and whatnot, and then it'll just reflect back in terms of their people's ability negotiate. It's like, okay, hey, is it going to be like the 3 years worth of RAS in one go or 2 years worth of RAS in one go type of a thing? I think that's up to the people's ability to negotiate. Let me leave it at that. I think I am not, it's definitely a little more complex product than an AMR, but I wouldn't judge it until I see hundreds of units volume, then say, okay, look at this hundreds of units volume, this is what it is. But all I can say is that it can be economically made for all parties.
All right, fair enough. Now, another issue with humanoid robots that I've seen raised is their ability to work collaboratively alongside humans in a natural way. And, we've heard of companies like Fur Hat Robotics that is working on this. But what's your take on this in terms of natural language work with humanoids in industrial setting, in light of all we're seeing with the various co-pilots coming into the market now? I was curious to know where things stand with that on the humanoids front.
Yeah. I think that the human-machine interaction is a complex science, right? It's not just a science. There's also behavioral stuff. There's all sorts of things as well, right? So I think more stuff will happen. More things will get incorporated and things like that. But the basics are, I think, of two things. One is interactability, where you can communicate or you can give a instruction. The robot is able to understand it, and then so that basic level of interaction. And then the second is safety, right? Like make sure that it's safe to work along with humans, right? Those are the two things are the first principle stuff. And then the second principle would be like you add more layers of behavioral stuff so that it doesn't come across as unnatural or intimidating and stuff like that, right? So I think the first layer is being addressed right now. Agility is actually driving some of these things for humanoids in terms of safety, how to think about safety, and creating a forum of different humanoid manufacturers to all kind of agree or at least figure out like a acceptable norms type of a thing. So the safety and then the basic level of interactivity is being addressed. I do think that there is more things that you could do. How the eyes blink. What does it indicate? All those things. They're all more behavioral rather than logical, right? Like, if a big truck comes next to you, you automatically move to the little bit on the other side, even though there is no difference between a big truck and a small car in the next lane. But our behavior, we just tend to move away from it a little bit, type of a thing, right? So there are things like that which are more human behavior driven. I think those things can be incorporated, and I think like the robotic companies will progressively incorporate these things, right? There are some who are addressing this a little bit more head on. There's others who are probably doing the basics first and then adding stuff. So I think it requires all hands on deck. Fred has done a great job, and one of the companies that didn't end up investing, but we know them, called Diligent Robotics. They deploy robotics in the hospital system, and one of their research really come from University of Texas, where they had worked on this human machine interaction. So a lot of the behavioral things in terms of how do you sit along with humans, what cues does a human really take, and then how do you make sure that you fit in naturally. They've done a good job as well. So I think it's going to be all hands on deck. There are companies that are going to improvise on that. There's going to be other companies learn from that as well. I think it's a progressive thing that we're going to learn and we're going to deploy. As you deploy more, we're also going to find out that, hey, this is the issue. We got to figure out a way and whatnot. Right? So one is obviously the approach, and then the initial plan of action, and then people are going in progression. But there's also going to be a lot of things that we want to learn as well.
So last question, Karthee, when it comes to automation of any type in manufacturing, it's rarely just about the technology. It's obviously also about the people and the culture, in the company as well. So considering that and, really how fraught the concept of humanoids is regarding the impact they could have on human workers, what considerations should manufacturers keep in mind when they begin exploring the integration of humanoid robots into their operations?
Yeah, it's an interesting question. As an investor, I have some idea, but I think as a robotics companies, they think about it a lot more. I think the first thing I would say is that it is not a human replacement. I think that's the first thing, because if that is the way it is set up, or if that's the way it is positioned, or if that's the way it is construed, then I think we're missing the point. Because I think that's not the way I think about it. Is that, and the way a lot of the companies that I have seen think about it is that, how do we augment it, and then how do we make sure that the humans are not doing the repetitive, more dangerous, or even even if it's not hugely dangerous, it's more tasks that people cause injuries and stuff like that. So if you think of it as how does this technology augment the human experience, human life, human work environment? That's the first step in my mind, right? I think if you miss that, then I think we're all doing a bad job, right? I think as long as that part is well understood, then I think there is more interest from everybody involved, and as they deploy this going forward. And then in terms of ethical considerations and stuff like that, the basics of robotics hold through, right? It needs to make sure that we can't have a 1% error is okay type of a thing, right? When you're working along with humans, it has to be accurate. It has to do its job, but it has to not be harmful to humans or harmful to the environment 100% of the time, right? So so all those basic robotic stuff are important as well. But what we have seen is that if you only look at it, I'm going to just replace humans with these things, I think those are the places where they actually struggle, I feel. Right? I think they feel that, this is a way for me to increase productivity, it's a way for me to augment the experience and whatnot. That's where they've done better job, right? So I think that's the way I will think about it, in terms of as you start deploying. We have been using tools, we've added computers, we've added a bunch of tools, and this is like an additional tool is what I would say. It's an automation tool, it's a different form factor and all those things, right? I think as long as we get everybody go along, because we help them understand or help the company understand that, I think those things will be successful deployments. And we are seeing different form factors, not just a humanoid, different form factors, and we are seeing when it's approached the right way, they are all welcomed by everybody around. And if it's not done the right way, you could see a bunch of friction.
So thank you again for joining me for this podcast, Karthee. And thanks, of course, to all of our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.